In this video, we come to an interesting tabular approach to looking at the chain rule and function composition. And what we're given in the table are values of x and values of the derivative of f of x at each of those x values. Then we're given some other functions that are some types of function transformations based on f of x. And we want to find their derivatives and complete the table for each of those x values for those particular transformations of f. So let's see what that looks like. We're given g of x is equal to f of x minus 2. So the derivative of g of x, g prime of x, will be the derivative of f of x minus 2. The derivative of f of x is just f prime of x. The derivative of negative 2 is 0. And so what this says is that if two functions differ only by a constant, they'll have the same derivative. And so we can complete the row for g prime of x since the two derivatives are identical. And that's all there is to that. For h of x, if h of x is 2 times f of x, then using the constant multiple rule, h prime of x will just be 2 times f prime of x. And so for each x value, the values of h prime of x will just be the values of f prime of x, but doubled. So all I did there was double each entry in f prime of x to get h prime of x. Now r prime of x is f of negative 3x. So this is a function composition, and it's going to involve the chain rule. So r prime of x will be the derivative of the outside, leave the inside alone, or f prime of negative 3x, then times the derivative of negative 3x, which is negative 3. And so that will give negative 3 times f prime of negative 3x. Now what that tells us to do is, for any given x value, multiply that x value by negative 3, then evaluate, find the f value of f prime at that new number, and take and multiply that new number by negative 3. So let's see what that means. When x is negative 2, r prime of negative 2 would be negative 3 times f prime of negative 3 times negative 2, which would be positive 6. So we would need to know what f prime of 6 is, but there are no values for f prime of 6. So we really can't answer that question. R prime of negative 1 would be negative 3 times f prime of negative 3 times negative 1, which would be positive 3. So we're going to look for f prime of 3, which is negative 4. And finally, negative 3 times negative 4 would be positive 12. R prime of 0 would be negative 3 times f prime of 0, since negative 3 times 0 is 0. And f prime of 0 is negative 1/3. And so negative 3 times negative 1/3 is 1. R prime of 1 would be negative 3 times f prime, negative 3 times 1, which would be negative 3. And since we don't know what f prime of negative 3 is, we can't answer that. R prime of 2 would be negative 3 times f prime of negative 3 times 2, which would be negative 6. And we don't know what f prime of negative 6 is, so we can't answer that. In the same way, r prime of 3 would be negative 3 times f prime of negative 9, which we don't know because we don't know what f of negative 9 is. Alright, so we'll go on to D. S of x is f of x plus 2, and so s prime of x would be f prime, leave the inside alone, which is x plus 2, times the derivative of x plus 2, which is 1, and so we just get f prime of x plus 2. So s prime of negative 2 is f prime of negative 2 plus 2, which is 0, and f prime of 0 is negative 1/3. S prime of negative 1 is f prime of negative 1 plus 2, which is 1, and f prime of 1 is negative 1. S prime of 0 is f prime of 0 plus 2, which is f prime of 2. That's negative 2. S prime of 1 is f prime of 1 plus 2, or f prime of 3. And that's negative 4. And you can see that we've been going across. The next one, s prime of 2, will be f prime of 4, which we don't know. And s prime of 3 will be f prime of 5, which we also don't know. And so that takes us through problem 107.